Okay, so let's start. It's 1:30 and welcome to Global Summit. Welcome to my second session of the day, but talking about backup, which is a subject that is dear and near to my heart. I have a long background in backup software specifically, but it's a unique session for our Global Summit because I have two very esteemed uh, co-presenters here that are not working for InterSystems. Prashant, which I will not butcher your last name, from Catalogic ECX or IBM, and David from CommVault that will help me present this session. The way I'm going to do it, I'm going to talk a little bit about what we refer to as Cache Online Backup, our backup facility that's built into the product, and then talk about external backups, and both will present their solutions. Now, just raise of hands, how many of you guys are using Cache Online Backup? How many of you are using external backup tools? Okay. So for those of you that were not in the previous session, talk a little bit about business continuity. I'm Oren. I'm responsible as a product manager for data resiliency and business continuity, all those options that, so mirroring, backup, etc. When we talk about business continuity, we're talking about the fact that your application needs to be up and running. And the expectation today is that it's up and running 24/7, 365, whether you're doing maintenance, upgrade, hardware changes, you name it. The expectation from the customer is that we don't care. We want it up and running, right? And this is also our expectation as consumers. In order to achieve that, there are a lot of pieces to that puzzle, whether it's hardware-based redundancy, RAID configuration at the storage level, fault tolerance at the hypervisor level, so you have two CPUs tracking one another, so if one of them fails, the other doesn't, redundant power supplies, all those things that manage hardware redundancy. And there are things that manage, and we talked in the previous session about mirroring. So redundancy that built into the data, how do you create two copies of it, etc. And then the application, the ECP, the application level, to create that same redundancy at the application level and the connection. All of those systems are in place in order to ensure business continuity. Having said that, all those will not solve the problem of a user going in there and making a user error. If you look at the latest ransomware attack, if you got targeted by that and your entire, I think there was another MongoDB attack last week, and all your data got encrypted, well, all the high availability in the world won't help you in those scenarios. That, together with regulations that require us to keep data for 7 years, for 5 years, for the life expectancy of the patient, for those of you that are in healthcare, require us to start creating copies of the data, keeping them, whether they're online, off-site, somewhere in Nevada under a mountain, just for the sake of safekeeping, it doesn't matter. That's the requirement that we have to comply with. So backup as a paradigm, creating that additional copy of the data and keeping it separate is still a requirement. And in order to achieve that copy, we have a couple of ways of doing that. So let's talk about Cache Online Backup. Cache Online Backup is pretty archaic from many perspectives. This is how it works. First of all, we get a list of all the allocated blocks for a database, for globals, etc. Everything that we're trying to back up. So we're starting to copy them one by one to a separate file, creating a backup file. So just going through all of them serially, and then move to the next backup in the list, to the next database in the list, and continue to append to that file. Once we're done with that, we're looking at what has changed since. So have there been any updates to that database? In our case, there are 2 blocks that have been updated. We're now copying them to the end of that backup file, and that backup file looks a lot like, if any of you know the TAR, the tape archive format, that's pretty much what it looks like, so it's very similar. So it's an iterative process. You go, you copy all the updated blocks, you check if there are any additional updated blocks, etc., until you get to a point in time where the number of updated blocks is small enough. And it's hard to quantify. If Ray was here, we would probably be able to pull out the formula and explain exactly how do we calculate that formula, saying small enough. But at some point, we reach a decision, it's small enough. At this point, we stop everything. Nobody is updating the databases anymore. All the updates from a user perspective, they see no interruption. Everything is still happening in memory, but we're not writing it anywhere, and definitely not to the database. So at that point, we do the freeze. We write the last updated blocks to the end of that file, and at that point, we're done. Now you have a consistent copy of all the databases updated to that point in time. Now, when you talk in backup terminology, there's the recovery point objective. When you talk about snapshots as an example, in most cases, when you initiate a snapshot at 6 a.m., what you expect to receive is a copy of that data as it was at 6 a.m. Here, if you followed me, it's the other way around. You start the backup process at 6 a.m., and let's say it runs until 10 a.m., you'll get a copy of the data as it was at 10 a.m. And that's important because when you're trying to figure out the recovery point objective, that's your point in time. So restore options from that backup, backup options. You can do full backups, which take all of those databases, all the changes, so you can restore all of that. Obviously, there are incremental backups and differential backups. Incrementals are simply what has changed since the previous, just the previous backup. So incremental 1 included 2 blocks, incremental 2 included 2 blocks, and if you can see, there's some overlap there. And then there's the differential. Differential is slightly different than an incremental. Differential includes all the blocks that have changed since the last full backup, while incremental is the previous backup. Obviously, once you have all that information, you can, hopefully, you want to use it in order to do restores. But before we talk about restores, a couple of points about what we're backing up. As I mentioned earlier, all we're backing up is the databases. That's it. If you have anything else, the binaries, installation directories, the CSP files, etc., those are outside the scope of our Cache Online backup. So you have to handle those separately in order for the restore to actually succeed, because at that point, you restore the databases. If there's no cache.exe, nobody will read the databases. If there are no files for the CSP, web pages won't be generated, etc. So keep that in mind. Restore options, again, the most obvious one is full system restore. I had the entire thing go away for whatever reason. I need to rebuild that server together with the database, the operating system, and everything in between. Database only restore, that's handled pretty well by Cache Online backup, and then restore or migrate the database to a different system. That's also part of mirroring that's mainly used for migration purposes. So any restore operation from Cache Online backup, because of the way that that backup file is constructed, requires the processing, or we have to read through that entire file. Now, sometimes the cost ain't too much, and that's reasonable, but in many cases, it's processing power. And when you don't have the time, you don't have the time. Last but not least, whenever you're dealing with database encryption, it requires special handling. So depending on, the Cache Online backup does not encrypt. You can put it on encrypted tapes, on encrypted disk, on encrypted, etc. But when you restore it, it comes unencrypted, and then you want to enable encryption as well. If you're running into those issues, and please come find me later on, let's talk about those special considerations. I think those are all the points here. Some backup best practices, and I think this cannot be repeated too many times. First and foremost, test your backups, or better yet, test your restores. Too many of us are just doing the backups. We comply with the regulation. We know that we have an additional copy sitting here or there, and we rely on the underlying huge amounts of redundancies that we've built into the system, so nothing will ever happen. The problem with that approach is that something always happens. And it might be a system administrator doing something unintentionally. It might be somebody pushing the wrong button. It shouldn't be a disaster type of event, but you will need to do a restore. So test those, test your disaster recovery scenarios on a regular basis. Consider your recovery time objective. So how much downtime can you allow yourselves, or your business can allow himself? Generally speaking, the less downtime you want, the more expensive the solution is. That's a good rule of thumb that holds for the last 15, 20 years. Consider your recovery point objective, which answers the question, how much data can you lose? So the worst of the worst happened, and the 2 data centers that you had as disaster recovery both flooded at the same time. What now? I can go back to, is yesterday okay? Or does it need to be 5 minutes ago? Or maybe a week ago? And then apply all the changes, assuming you have them. In the restore scenarios, you don't have to, it can go all the way from restoring a database, run integrity checks, see that your backup is fine, all the way to get your application up and running and see that customers can cut and switch over to that restored backup. So all of those scenarios need to be addressed. At least have a plan, better yet, test them. Test disaster recovery at least twice a year. So cut over, I've seen customers that once you get into the habit of doing that, they cut over once every 6 months, they cut over for a day to the disaster recovery data center, and a day later they cut over back and everything. Nobody even feels it at this point. Yeah, it might be a little bit slower, but that's fine for a day. And keep some copies of data offline. Everything that's online can be susceptible either to things like ransomware or to hardware failure. So keep stuff in cold, if you will. But looking at our technology, there's also the database resiliency. So when you look at Cache, when you look at Ensemble, there's 3 components to it. There's the cache.dat, there's what we call the widget file. I suspect some of you are already familiar with that terminology. It's the write image journal, and then there are the journal files. Once you grab these 3 components together, from our perspective as a database, that's consistent, because everything that's been accepted by Cache as a transaction is first written to the widget file, then makes its way to the journal file, and then make its way into the database. So if you have those three components, Cache Startup does everything it needs to do in order to make those consistent. Now, I mentioned earlier that part of the addressing full system restore has to do with everything outside Cache. This is definitely something we see as outside the scope of Cache. This is where we integrate with external backup vendors, and their focus, just like our focus is on databases, on database performance, on multi-model, etc., their focus is on managing backups. So if you want to tell the backup software to create a backup every hour, keep the weekly for 3 months, and then keep the monthly for 3 years, or whatever combination, things that some of you have scripted through Cache Online Backup, they know how to do all these things for you. They know how to leverage hardware snapshots. They know how to integrate with different tape archives. They know how to manage tape encryption keys, etc., etc. And that what I wanted this to focus on. I want you guys to realize that once you cross a certain threshold of amount of data that you're managing, once you cross a certain threshold of my application business is yay big, it's time to forego. The Cache Online Backup is a great tool, but it will not scale. Now, if you need to comply with regulations, the way to go is go and have a backup solution, a backup software that does all that management for you. And over the last year or so, we started more and more integration with external backup vendors. We have two of them here to talk about that. The main key in that integration, it's threefold actually. The first one is the backup vendor needs to be able to inventory our system. So when you look at it as Cache administrators, you see, okay, there's InterSystems Cache, and it has these databases. The other piece is, how do you do the backup? In order to do that, first we need to go back to that freezing methodology where we tell the Cache system, okay, hold the writes for a couple of seconds so we can create a copy, a consistent copy of all those dot files, widge, and journal files, and then letting it know that, okay, we're done. We created a copy, you can continue right to the disk, therefore ensuring consistency. So the first one who's going to speak today is David Bova from CommVault. David?
Thank you. Thank you, Oren. Oh boy, so it's over there. Well, we'll survive. Okay. So 27 minutes. All right. Thanks. So just a little bit about CommVault. We sit in the enterprise data management space. So today I'll be talking about backup and recovery for cache, but you know our product suite encompasses a lot more than just that. I'd say one of our biggest points right now is workload portability. So not just getting your backups done, but where can you then push that off to in a DR situation? Is it going to be public cloud vendors, private cloud vendors, etc.? We've been doing this for about 20 years now. We just had our 20-year anniversary last year. We've got close to 2,800 employees around the world, and all of our code has been developed in-house, which is a pretty stark contrast to our biggest competitors, who are all three-letter acronyms, who have built their products by acquiring other companies. A little bit of an overview about our technology. What we call our CommVault data platform is really just a virtual repository for all the data that's going in and out of it. And basically, once you add a storage device, whether it's going to be tape, cloud, or disk target, from that point on, we're going to manage that. We're going to manage the movement into and out of it, and so you don't ever have to worry about where it goes. You just need to know what you want and when you want it from. We have a few dozen different APIs that we work with to get data out of applications, whether that's the common ones like NFS, CIFS, S3, down to DICOM, HL7, XDS. You're going to see that there's multiple different ways to back up or protect anything that you want. You can either write into us or have us pull from the application. Once it gets down into our platform, again, we don't want you to have to worry about where it's going from there. So one of the options that we're bringing in now is our hyperscale option, which allows you to use commodity compute and storage. You just buy a bunch of big servers, put them together, put the CommVault software. We'll manage it from there, so that you don't have to worry about buying a NAS or SAN for your backup data, because that's just kind of a waste of money. But we're moving there, trying to get more people on there as well. So one of the biggest parts of our product catalog is called IntelaSnap. That's our snapshot management tool. Basically, the idea is that it's a structure, a framework that we can use for a huge number of applications and a huge number of hardware arrays. And because we own the process from snapshot to restore and everything in between, the indexing, the backup copies, everything like that, it makes it a lot simpler to manage. So a few of the benefits of using a snapshot solution like IntelaSnap, I think this got kind of squished, sorry. But as I was saying before, you can restore confidently. It doesn't matter where the data is, as long as you know what data you need and where you need it from, and when you need it from. Just tell CommVault, and whether it's still on the snap, whether it's on the disk, whether it's on tape or in cloud, we're going to pull it back from the best target. Restoring autonomously, at 2 o'clock in the morning when something goes down, you need something restored. You don't want to have to wake up your SAN admin, your networking admin, your DB admin, just to get a restore done. What you can do is write a workflow that does the restores for any systems that you need, and then you can just have a help desk operator click on a button and run the restore. Obviously, that's best case scenario, but that can be done. We have customers that operate that way. Changing storage. This is, storage refreshes become a bigger and bigger thing as more of these new vendors come out with, all sorts of new all-flash arrays, and moving from one to the other can be a big part of, can be a big challenge for people in saying, oh, we can't do this until we've got that move done, etc. With CommVault, if you've got your backups running on, say, NetApp storage today, but you want to move to, say, Pure, all you need to do is hit the drop-down menu. Oh, you made the screenshot bigger, thanks. You hit the drop-down menu and you just scroll down to Pure and save it. That's it. Robust error reporting. So, we've got probably 10,000 plus IntelaSnap customers now. They've been running it for 7 or 8 years total. So we've got, tens of thousands of cases where we've run into issues in the environment. CommVault was able to figure out there was a problem, but we didn't know what kind of problem. We went back and updated the error codes so that you get very clear reporting and very clear errors if something does go wrong. That should point you right in the right direction. But if you can't figure it out on your own, you got one number to call. You call us, we're going to very quickly tell you where that problem is, and if it's not within our software, we'll tell you who you need to call. Speed is obviously very important. We're talking about production workloads, especially in a lot of cases this is going to be, patient lives on the line. So just as an example, we are pretty much infinitely scalable for a lot of these jobs. When I was working with a customer just a little while ago, we set up backups. They were running, from an all-flash array and saving onto commodity disk, and we were able to hit 3.6 terabytes an hour on those backups. As I did the math, I realized that was the limit of 8 gigabit fiber. So the point is, whatever hardware you give us, we'll scale up to that level and then give you the speed that you need. And of course, for any cache environment, you're going to have, for every one production environment, you're going to have several test dev environments. What we can do is automate the refreshes of those environments. The array support for that is a little bit limited. You can see at the end here, it's VMAX, HDS, 3PAR, NetApp, Nimble, and Pure. But we're adding new ones every year. So just a quick rundown on how this actually works. Again, this is really just for the backup process. At the beginning of the job, we contact the production cache system to gather the volume information to create the index. From there, we're going to quiesce using the script that Oren was referring to. And then we're going to contact the SAN, tell it to create snapshots of all those volumes. And then from there, we'll unquiesce the database. Now from here, you've got your quiesce snapshot copy. You can use that for a revert. You can use it for a restore. You can use it for your database updates for your test dev environments as well, whatever you want. But obviously, as Oren was saying, we want a copy that's off-site. We want a copy that's on some other network. So what we do is we use a proxy server, which is usually our media agent. We tell the SAN to mount those snaps onto it, and then we read that data out onto your disk, tape, or cloud target. All right. So here's a list of the snapshot engines that we support for cache. There are a few more that don't make the list that wouldn't be compatible with cache at this point. But basically, this list here covers over 250 different arrays that are out there. And if you have an array that's not on this list and you're running cache workloads on it, I would love to hear about it. We can definitely see where it is on our roadmap, and what we can do to add that support later on. Beyond cache, we have 21 other agents that are also integrated with IntelaSnap. If you have to worry about any other kind of databases, all of these are integrated with that same snapshot protection, the same drop-down menus, the same simplicity of the GUI. And again, if you don't see it in here, I'd be surprised. But there's very few that we can't integrate with. So just as a wrap up, I did this faster than I thought. Sorry, guys. CommVault provides three main goals for you. The flexibility for having all those different storage engines, but beyond that, we've got over 40 different object storage platforms we can save to. Hundreds of different tape libraries. So there's probably a dozen different cloud vendors that we can push workloads into. And again, we've got all the agents with snapshot integration for what we're talking about right here. The simplicity. The single GUI for everything that you need to do, and again, everything that you want to do within CommVault can be boiled down to a single button that somebody can click in the middle of the night. The single code base that's been developed in-house that enables a lot of that, and the workflows that I was talking about for the environment refreshes. And again, because we're one of those enterprise vendors, we've got over 20 years of experience with this. We've got over 25,000 customers, a couple of them in the room today. We have lots of references you can speak to if you're ever concerned about any of this stuff. And then our support centers in the UK and in Australia provide round-the-clock follow the sun coverage to make sure that no matter what time of the day you have an issue, you're going to get someone who knows the stuff and is able to communicate with you clearly. That's all I got.
David, next up, Prashant from Catalogic, DCX, and also OEM by IBM.
Hey, I'm Prashant Jagannathan. I'm with Catalogic, and I'm going to talk about IBM Spectrum Copy Data Management. This is a product IBM OEMs from Catalogic. It's a quick overview of what, why, and the how. What we do is integrate with storage array snapshot and natively with cache, so we can make an application-aware storage snapshot and orchestrate a lot of operations. A colleague of mine always says snapshots and hardware snapshots and backups are like gym membership, right? Everybody has it, but nobody actually uses it. So basically the idea behind our product is to enable users to leverage snapshots for backup copies and also automating operations like disaster recovery, test dev automation. Like you don't even need to click. Some of these operations are automated, so you can have a daily refresh of your DR environment or daily refresh of your test environment, and everything can be controlled through REST APIs as well. So it's designed for modern and make it as easy and simple as possible for the end user. So even the product the configuration steps are fairly easy. Spectrum CDM comes in deployed as a single OVA file. So all you need to do is give it an IP address and register your application resources. Everything is agentless. So all you're providing is information about the databases and the storage systems. So the databases that we support on top of cache are Oracle, Microsoft SQL, SAP HANA, and hypervisors VMware and Hyper-V. And the storage vendors that we support are NetApp, IBM, EMC, VNX, and Pure Storage. Like I mentioned before, CDM deploys as a single OVA file, and it's capable of automating and orchestrating hundreds of thousands of instances. So it agentlessly registers the resources and builds a catalog, a metadata catalog, which you can use to create backup copies or automate the operation of recovery from a snap or to do full recoveries. The same database can be used for mounting a test dev copy and also perform some of the operations like DevOps. If you want a daily copy all through automated API orchestration engine, you leverage some of the tools already like Chef or Puppet or any of these automation tools. Use those tools, We have plugins for them where you can connect the Spectrum CDM product and use those automation engines to refresh your data copies or even create schemes for backup and recovery. A quick workflow of how it actually works. So IBM Spectrum CDM leverages APIs, the external backup script that Oren was talking about. First, it goes ahead and identifies the actual location, so it does an inventory process to collect all the instances, all the database files that correspond to that instances, and builds a metadata catalog. Once we understand that, we map out the database to the corresponding storage system. So where the logs are located, where the journals are located, where the database are located, and what actual storage system it's on. So the mapping process is done, and it creates it initiates the external backup script to freeze the database and take storage snapshots. Again, these are orchestrated automatically in the background. From an end user perspective, all they're doing is registering the cache server and registering the storage system. We'll automatically map the systems behind the scenes and create an application-aware, database-aware snapshot. CDM also supports storage-based replication. The one thing to note is the data does not flow through the product. So there is no media servers, media agent that you need to configure. Everything is driven through APIs, either at the storage level and the replication that the storage provider enables. So from a management perspective and configuration perspective, it's very less information that you need to provide to the CDM server. In terms of replication, like I mentioned before, we orchestrate storage system-based snapshots and replicas. So any replication that is enabled through CDM is already an app-aware copy. So from either the primary snapshot copy or the replicated one. So if you have a copy on-prem and a DR site where you have another storage system, from either one of those, you can pick within the UI to say, refresh my copy from the replicated snapshot into my DR environment or into my test environment. So the metadata catalog automatically identifies where the actual snapshot is located, and from any of these copies, you provide the same type of recovery. So if it's on-prem, you want to recover from the production system, we leverage the local snapshot. If you want it from the DR side, we leverage the replicated snapshot. So from a usability perspective, it makes it much simpler, one less thing for the user to manage. And these copies are available for instant recovery. So this is a key feature and a key differentiator. So instead of actually restoring and rehydrating the entire database, we can quickly spin up a copy of the cache instance to any server. And for that, we can just map it to any Linux server. You don't even need to have cache installed on it. We'll bring up the entire instance instantly from a snapshot. The way it works is we'll mount the snapshot copy to the system, be it a VMware system or a physical server. We'll create the actual mount points within the file system and load the instance. So from an end user, all you're doing is pointing to a Linux server or a VM, and behind the scenes, we'll create the entire end-to-end workflow. Not just mounting a snapshot, but also bringing the database to a state you can actually work with. And these instant clones can be leveraged for testing purposes. If you want to run development code against it, instead of giving access to the production environment, we'll give you a clone version from a near production environment. So it's a snapshot which you can use it right away. And there was another use case about upgrades. If you want to perform upgrades, instead of doing again on the production instance, take a snapshot, instantly mount to any location, run your updates. And behind the scenes, if you want to promote that to a production, we'll sync the data back and bring it back in your production environment. The three steps, these are the three highlights that I wanted to point out. The first step is a registration process. It's an agentless one-time registration. Again, we support multiple databases. So the user will select InterSystems cache, provide basic credentials to it. Since I mentioned it's agentless, we don't have a persistent agent to manage. So no rebooting the server, no need to upgrade. We'll automatically leverage the system credentials to identify what's the version that is running and centrally manage it. The next step is backup. So once we register it, it'll show up the instances and all the databases underneath that server, so users can go ahead and pick what they want for backup. Behind the scenes, it'll do the storage inventory as well as the cache inventory to identify the lineage and the location. On the restore side, again, like I mentioned, you can take a database from one location and bring it up in a completely new environment. It doesn't need to even go back to the same server. We'll bring it up in a completely new environment where you don't even have to have cache installed. Just point to a Linux server or a VM, and it'll instantly mount the database and make it available for use. So again, it goes beyond just typical backup and restore. You can use this for multiple different purposes as well. In terms of data delivery, again, you can make it automated. Everything is run behind a scheduler. You can use external schedulers as well. CDM comes with its own native scheduling. So this is for both taking backup if you want to do hourly backup, daily backups, etc. Now since it's a snapshot-based solution, it now allows you to have multiple recovery points. You don't need to just do one backup over the night or do a full backup once a week. It's all incremental, and you can now run this multiple times during the day without affecting the performance of the system itself. You can run on-demand recovery as well. So majority of the times, if you're doing database refresh or something for DR systems, it's usually scheduled. But if you want to ad hoc system restores or instance restores, there's a push button mechanism to do that as well. Since there's a granular role-based access control, you can provide end users access to the portal. So for example, if you want to give access to a DBA or a developer, once they log in, they'll only see the databases they have access to, and they can leverage it to create their own DB refresh. And everything is built on REST APIs, so if you want to integrate it with any of your automation tools, we have APIs available for doing external calls to the CDM appliance. That's it from me.
I think that's pretty much covers the slides we're playing.
One additional plug, we have a booth, we have a table in the hallway, so if you have any follow-up questions, feel free to reach out to us. And thanks, Oren.
Questions? None? In that case, I urge you to fill out the survey, give them back at registrations or email them, and come talk to us at the Tech Exchange. We have most of our developers here, so covering anything, not only backup and mirroring and high resiliency, but anything that has to do with Cache, Ensemble, InterSystems, Iris, and a fair amount of health share and track. We have developers here. That's basically the reason that we run Global Summit. So you can interact directly with the developers. They know a lot more than me about their respective areas, down to the bits and pieces. We have our support team here, at least from that perspective. Go show your respect to them. They are the guys who are talking to you day in and day out, doing an excellent job. I think John covered it pretty well in the keynote earlier today, but that's about it. Thank you.